Took a look at how to find out what your investment would be worth at the end if you put a certain amount in and left it there, did nothing else with it. Today what we're going to take a look at is if we want to have a certain amount saved at the end, so maybe we're saving for a car, down payment on a house, what do we have to invest now to have that money sometime in the future? And that's called the present value of an amount. So it's the principal or present value of what we need to put in now to have that amount at the end. To find the formula for present value, we simply rearrange our compound interest formula, but instead of using P or principal, we use PV for the principal. So we're going to take a look at A equals P times 1 plus I to the power of n, and we're going to make that P PV. So what we're going to do is take this 1 plus I to the power of n to the other side, where it becomes dividing. So PV is equal to our amount divided by 1 plus I to the n. Now, we know that we can simplify and write this without having it as a fraction, that we're going to rewrite that 1 plus I to the power of n on the top. If we bring that to the top, that just means that we're going to change the exponent to a negative. Okay, so it just makes it a little easier to calculate it if we bring that to the top and make it a negative exponent. And we remember that from our exponent laws. So we're going to use that in example 1. We are going to figure out that Tom wants to have $8,000 3 years from now for a down payment on a car. How much must he invest now at 4.5% per annum? And remember, per annum is simply financial way of saying per year, compounded monthly to provide the down payment. So, starting with our formula, as always, and the amount that Tom wants to have is 8,000. Remember that we have to adjust our I and our N for per period. So we're going to take our 0.4% as a decimal, and we're going to divide it by 12 because we're figuring out the interest for each month. And that means as well that for the 3 years, interest is going to be calculated 12 times a year for 3 years, which means we're going to have negative 3 times 12 as our exponent. Now, we can put this all into our calculator in one step. We don't want to simplify our 0.045 because that's not going to be a nice round decimal. So we want, if we can, to do this all in one big step in our calculator. So what we're going to do is we're going to start by figuring out what our decimal is. So 0.045 divided by 12. Then we're going to add 1. So that gives us our answer for the brackets. Now we're going to do to the power of negative 36. And sometimes you're going to have to put in 36 and then your negative button to change that exponent to a negative. Once we get that answer, then we're going to multiply by our 8,000 and we get 6,991.49. And we want to have a therefore statement. So Tom needs to deposit with our dollar signs and our 2 decimal places, $6,991.49 now. Example number 2, we're going to find the present value of each amount. So first of all, $15,000 due in 15 years, invested at 4.8% per annum, compounded annually. So again, starting with our formula and subbing in what we know. So we know that the investment is going to be worth $15,000 at the end, and we're going to change our 4.8% to our decimal. Remember, we always move our decimal spot 2 spots. Now, we are just doing this annually, which means that we don't really have to change anything for our I and our N because it is only happening once a year. So simplifying that, we know that we can just put into our calculators, and again, probably doing our exponent first is the easiest part. 1.048 to the power of negative 15 multiplied by 15,000. So we get 7,424.58, and again, dollars and cents, rounding to 2 decimal places. So our present value is $7,424.58. Okay, so that's what we would have to deposit now for it to be worth $15,000 in 15 years. For part B, we're looking for $10,000 in 6 years. So present value, and again, starting with our formula, we have 10,000, and we're going to take our 6.75% as a decimal, keeping all of our decimal spots. Compounded quarterly means 4 times a year, so we have to divide our interest rate by 4, so we have an interest rate per quarter. And our exponent, we're going to have 6 times 4 because interest is going to be calculated 24 times on that amount over 6 years. So again, 0.0675 isn't going to simplify into a nice round number. So we're going to put this into our calculators all in one big step. 0.0675 divided by 4 equals plus 1 equals to the power of negative 24 equals and multiply by 10,000. When we do that, we get 6,692.34. And again, quick therefore statement, the present value is $6,692.34. And last example for today, $3,000 in 8 years, invested at 3.7% compounded semi-annually. And again, as always, starting with our formula, we need to have $3,000. We're going to change our our percent to a decimal. Semi-annually means twice a year, every half year. And our N then is going to be 8 times 2. We're going to calculate interest on that 16 times over 18 years, twice a year for 8 years. And again, 0.037 isn't going to round into a nice round decimal necessarily. So we're going to put it into our calculators. 0.037 divided by 2 equals plus 1 equals to the power of negative 16 equals and multiply by 3,000. And when we do that, we get 2,237.41. And we're going to do our therefore statement. Our present value is $2,237.41. And just as an aside here, if we wanted to know how much interest was earned, we would still take our amount, or what it's valued at the end, and take away what we put in to start with. Remember, our interest is always the difference between our amount, what's deposited, and what we take out at the end. If we haven't touched anything, that has to be the interest that was earned on that investment. So this investment earned $762.59 in interest. Okay, so that is how we can figure out what we need